always get the old after lunch session. So welcome to Windows Azure Storage Deep Dive. My name's Chris Auld. I'm from Intergen, based out of Wellington, New Zealand. I do a lot of work with Windows Azure, and in particular I've done a lot of work with the Windows Azure product group over the past 36 months in their early review cycles and then helping them to build out some of their training content. So this is actually some content that will hopefully end up on the MSDN site for you to download in the next month or so. So we're going to talk about Windows Azure Storage. We're going to have a bit of an all-up discussion around Windows Azure Storage and then drill down in some detail around initially blob storage and then, depending on how we track for time, Windows Azure drives as well. We're not going to touch much on tables. We're not going to touch much on queues. These are 60-minute sessions. We're going to be moving pretty quickly. So Windows Azure Storage provides us with highly scalable, highly available storage in the cloud. It is a massive bit bucket in the sky. By highly scalable, I mean that you are unlikely to be able to exhaust Microsoft's storage capacity no matter how much you throw at it. You will not have the financial wherewithal to be able to saturate their storage layer. By highly available, I mean that this stuff stores 3 transactionally consistent replicated copies of your data in the cloud at any one point in time. This stuff is not backed up. They rely on that duplication throughout the data center to provide your backup. You access it anywhere. It's accessed by a set of RESTful web services, and you only pay for what you use. So you're going to be paying 15 cents per gigabyte to store your data, and then anywhere from 10 to 45 cents per gigabyte to get your data in and out, depending on the exact topology you choose in terms of which geography your selected data center lives in. It is a set of RESTful web services. We can consume those RESTful web services from Windows Azure Compute, but we can also quite easily consume those RESTful services from on-premise applications. And indeed at Intergen, over half of the applications that we've built to date actually use Windows Azure Storage from on-premise clients. With Windows Azure Storage, you create a storage account. That storage account is going to be located in one of Microsoft's 6 geographically dispersed Windows Azure data centers. We're not going to jump into that in a whole lot of detail. The one thing to note, right, is that these Asian data centers are significantly more expensive for bandwidth than the US and European data centers. US European, 10 cents inbound, 15 cents outbound. Asia, 30 cents inbound, 45 cents outbound. I'll give you some tips on how to minimize those traffic charges in a little bit, and that's going to be by using the CDN. And in fact, the CDN is now delivered via 20 nodes. Anyone use a CDN at the moment? Akamai, LimeWire, anything? Anyone prepared to tell me how much they pay per gigabyte in traffic out of that? More than 20 cents? Yeah? You can have 20-cent traffic out of the Windows Azure CDN. And if anyone came to my session yesterday, I had a pretty good example of how you use that. This is a how session, not really a why session, folks. I'm not going to drill down a lot into the economics of this. Your account is secured with a 512-bit shared key. All access to that RESTful web service for trusted operations need to be signed by that key. So you sign those RESTful service requests. You can store up to 100 terabytes per account. You can have 5 accounts per subscription. If you need more than 500 terabytes, you can give Microsoft a call and say, I need a bit more than 500 terabytes, please. Anybody have needs beyond 500 terabytes? Not yet. Good. So we also have storage in the development fabric. The storage in the development fabric allows us to simulate what that cloud storage endpoint looks like so that when we're on the aeroplane to Singapore, we can still actually create our applications. Having said that, I'm a big fan of just using storage in the cloud right from the get-go. So I'll run my application in the Windows Azure development fabric for development purposes, but I'll almost always connect my application directly to cloud storage from the get-go. Right? The only time I'm typically using the development fabric for storage is when I'm working in an offline mode. The reason for that is that working with dev storage, right, there are some differences. Working with cloud storage does not really cost you anything, right? Because you're typically not going to be pushing much more than, I don't know, a gigabyte of traffic during your month of development work. You're not typically going to be storing much more than a gigabyte of data in your monthly development work, so it's going to cost you 30 cents a month. That's probably tolerable to most people. There are a couple of ways to access the Windows Azure storage endpoint. Firstly, it is a RESTful web service. That means you can consume it from any client that understands HTTP and XML. So you can consume it from Ajax, you can consume it from Silverlight, Java, JavaScript, Silverlight, right? Pretty easily. If you use a managed, and that is a full .NET managed environment, you can consume it using the Microsoft.Windows.Azure storage client API. And that is a managed wrapper that wraps that RESTful endpoint. So all it does is it makes those REST calls for you. If you want to have a look at what those REST calls actually look like, run this fella up, turn on Fiddler, turn off the HTTPS mode so you can see the traffic in the clear, and you can watch this stuff go back and forth. Right, so if you basically need to spoof up some requests, that's the way to do it. The security is a fairly simple approach, right? So in terms of secrecy, all communications to and from the storage endpoint can be secured using HTTPS. Right? You have a certificate on the server that you can use and trust that certificate from your client. Right? It is actually signed by a trusted certification authority, so it is trusted out of the box. And then you digitally sign those requests to the Windows Azure Service endpoint. So if you want to make a trusted request, and the trusted requests are anything which writes data and anything which reads data from objects that are considered read-only or protected. There are two levels of security. Basically, there's public and there's private. Right? So there's not a level of sort of granular security that you might come to sort of think of in terms of ACLs as you would have with a sort of a typical, say, Windows server. In order to get more granular security, we use a thing called shared access signatures, and part of what we're going to drill down into today is shared access signatures. You'll see we're moving reasonably quickly. That was the introduction. Everybody understand? All good? Who's used Windows Azure Storage a bit already? Oh, not many people. Perfect. Okay, so we'll be going reasonably deep here. So we're going to cover mainly blob storage. Blob storage is kind of the one that you look at and go, yeah, there's not really that much to blob storage. It's me just sticking files in the cloud. When you peel the covers off, blob storage has got all sorts of interesting possibilities. Who came to my session yesterday? Who saw my $5 solution to getting Slashdotted? Who thought that was kind of interesting? Right? I can show you a way that for $5 we can effectively give you infinite scale for many web applications. Right? What we do is we push the content into blob storage. It's a RESTful web service. A RESTful web service, if you do an HTTP GET at it, you get the content back. It therefore is a fully fledged static content web server. So what we can do is we can basically forward cache our content. We can have an application running on premise. We can push that content into the cloud. It's sitting up there, publicly available on that RESTful endpoint. We get approximately 60 megabits per second out of that endpoint. Right, so we have a high-performance, massive throughput web server that's costing us 15 cents per gig for traffic out of it and 15 cents per gig per month for the storage we put on it. We'll also, based on time, talk about a thing called drives. And drives basically wrap the blob technology, and they allow you to upload a NTFS formatted VHD into Windows Azure blob storage. You can then take your Windows Azure compute roles. Everyone familiar when I talk about Windows Azure compute? Right? Think of it a bit like sort of a virtual machine type thing running in the Windows Azure cloud. You can attach these Windows Azure drives into a Windows Azure compute role, and you can basically treat it as though you have a persistent, durable drive, NTFS drive, within Windows Azure compute. So we'll talk about those in some detail. So, blob storage. Let's start with sort of a bit of a hierarchy of blob storage. So at the top level we have an account, right? And so our account is what we create in the Windows Azure portal. We go in, we have a Windows Azure subscription, we go create new service. and we create a storage account. When we create a storage account, we give it a name, and we will then have an endpoint at accountname.blob.core.windows.net that is our blob storage endpoint. Within that, we can specify containers, and containers are really just a logical grouping of blobs. Having said that, containers do have an impact on performance, and what I mean to say there is that the more containers you have, the more performance you will potentially get. There is a degree of limited throughput per container. It's not well documented, but people have run some tests against this stuff, and you do get more throughput if you need really massive throughput by having more containers. Into each container we write a blob. Each blob has a name. We have two different types of blobs. We have what we call page blobs, and we have what we call block blobs. And we're going to drill down to those some detail shortly, but that's really what's represented out here. For most of the time, particularly when you're working with the storage client API, you're really going to be thinking about blobs in terms of named files at that endpoint. Remembering that it's a RESTful web service, so we will end up with a URL for each and every blob in our application. We can make that URL up by specifying the account name, by specifying the container name, and finally by specifying the blob name. There is no such thing as paths beyond the container. There are only named blobs. However, Microsoft support doing queries within a container and including a delimiter. So you can in fact include a / delimiter in your blob name and create something that is akin to a navigable folder structure. The main operations that we can perform against that blob storage endpoint are, surprise, surprise, HTTP verbs, right? It's RESTful. Therefore, what are we going to be able to do? Get, put, delete, post, right? Copy blob, snapshot, and lease. These last few, copy I hope is fairly obvious. Snapshot allows us to create a vector-only, read-only snapshot of a blob. So for example, we can say snapshot this blob at this point in time. That then becomes a new uniquely named blob in blob storage, and we can go and make changes to the underlying blob that was based on. Particularly useful for things like drives, where we may want to have a drive of reference data that we can snapshot at a point in time, and then continue to have other portions of our application updating the underlying drive without affecting those snapshots. We're able to associate metadata with blobs, right? So we can basically just create name-value pairs that we append onto our blobs. Your blob is always accessed by name, right? So as I said, there's no such thing as paths beyond the container. However, you can include some delimiters and you can basically mock yourself up a path structure by using some of the query features around blobs. Each account has one or more containers. We have one special container. That container is called the root container. You refer to it as string root. So it is a name container. Its name is string root or $root. Who can think why it might be really useful to have a root container? Anyone do any Silverlight work here? Nobody. Anyone ever tried to make cross-domain calls from Silverlight or Flash? Right, if you make cross-domain calls from Silverlight or Flash, Silverlight and Flash expect to find a client access policy XML file in the root of the host to which you're making a call. Therefore, if we want to be able to call blob storage directly from a Silverlight client served up from another web server, we need to be able to find that client access policy in the root. Therefore, we need to write it to the root container. Right? So it does mean that we can have files at the root of our blob storage. Because we have a unique URL, because we have that unique host, accountname.blob.core.windows.net, we can CNAME that host. So if you want to CNAME that host as blob.myapp.com, right, or cloudstore.myapp.com, that's pretty easy to do. And then you basically do have that fully functional static resource web server below that. We're able to set access control policies, public read, private, at the container level. Right? We can also set those at the blob level. We're able to list all of the blobs in the container. There is, strictly speaking, no true query capability there. We cannot query by metadata. So if you think you're going to be able to use the metadata to basically build up something that you can then query to pull certain blobs back, you can't. You're limited to basically querying by blob name or part thereof. So part thereof lets you query for that file tree. Throughput is pretty decent, about 60 megabytes per second per blob. And there's a good tiny URL link there. That takes you to some analysis work that the Microsoft Extreme Computing team did of actually looking at what sort of throughput can we pull out of Windows Azure storage based on the use of X number of blobs and or X number of containers. So if you need really high throughput, go and have a look at that. So the get blob operation can take parameters which allow us to list blobs out of our containers. So given a container that looks something like this, so we've got adventureworks.blob.core.windows.net. Our container is products, then we've got bikes, canoes, and tents. Right? So remember, products is the container name, and then we have a blob called bikes, whack, superduper cycle.jpg. Given that, we can submit a GET query to that endpoint, asking it to list using the delimiter of /. What that's going to do is return for us these prefixes. It's going to return bikes, canoes, tents. So you can see that it is reasonably easy to build up something that is akin to a file system using blob storage. Got a question? Just resting your arm. All good? Right? We can then go and do another get, this time specifying a prefix. So I want to get everything that effectively sits in the tents prefix. What that's going to return for me is a list of blobs. Question at the back. There is just one prefix, right? So again, if you've got, you can't, for example, say I want to get everything out of tents and everything out of canoes. Yeah, it's just one. Absolutely, because remember that if we had whack tents, if we had sort of tents, whack family, whack Taj Mahal, whack really big tent.jpg, right? The prefix would just be everything before the final delimiter. When we pull a list of blobs back out of blob storage, we're able to paginate those. And we paginate those either when the number of blobs we're returning exceeds a parameter that we pass in called max results, or it exceeds the default value for max results, which is 5,000 blobs. When we paginate, we'll get back what's called a continuation token, right? Or a marker value. And we pass that marker value back up to the service on subsequent calls to get more blobs out. There is no isolation across calls. So what that means is potentially you may have phantom read situations where you make the first call, you get back one blob, the data changes. Prior to you making the second call, that second call is not isolated. You don't have sort of some type of snapshot isolation across multiple calls. You do have snapshot isolation that carries through for the entirety of a single call up to the service. So let's have a quick look at the blob service. And actually I'm going to do this using a tool called Cerebrata Cloud Storage Studio. And Cloud Storage Studio is a tool that's a pretty useful bit of kit. And it basically allows us to connect up to our blob storage account. So you'll see here if I go to windows.azure.com, and I log in using my live ID, I have a number of subscriptions, only one of which is still active because I haven't paid for the rest. Right? So I've got a bunch that are read-only. I got some that carry over from PDC 2008 and so forth. Within this, I have 3 services defined. I have Gear Snatcher Web, which we're going to talk about tomorrow if you come to my session tomorrow. Plug. Right? I have Gear Snatcher, which is a storage service, and I have CAULD Storage, which is a storage service. If I drill into that, you'll see I have my storage endpoints defined. Right, so my storage endpoint is cauldStorage.blob.core.windows.net. So that's the endpoint I'm going to be able to make these RESTful calls at. You'll see I also have both a primary and a secondary access key defined. The reason we have 2 is it makes it easier to roll keys. Why might I want to roll keys? Maybe I come to a conference and I show my blob storage account to a room full of about 30, 40 odd people and then have to go and roll the keys on my production application afterwards because it's on the video recording at the back. Right? So we need to be able to roll keys. So it means potentially we can share keys with a business partner and roll that key out later on. We have what's called affinity groups and geolocation. So an affinity group, if we were to define an affinity group, that affinity group basically says everything that sits within an affinity group must be geolocated in the same data center. So for example, if we have Windows Azure Compute and Windows Azure Storage, we want them to live in the same data center for 2 reasons. One is performance, and 2 is if they don't live in the same data center, we're going to pay traffic charges for all of the traffic going out and all the traffic coming in down between the 2 services. Right, so we can use affinity groups to do that, or we can hard code the geographic location. So in this case, I've hard coded the geographic location. We have an ability to turn on the CDN, and you'll see that I have enabled the CDN for this storage account. We're going to talk about the CDN in some detail shortly. And I'm also able to specify custom domain names that I want mapped into my storage account. So if I want to have blob.myapplication.com, I define this right here. I can then connect to that using Cloud Storage Studio, and I'm able to browse all of the containers in my application. So you'll see here I have my list of containers. You'll see I have the root container. If I drill into the root container, you see I must have used this for a Silverlight application at some point in time because I have a client access policy.xml file. And in fact, we're going to have a look at that in the next demo that's coming up. So let's start to drill into it with a bit more detail. Let me just get rid of this. So I spoke earlier about this idea that we have 2 types of blobs under the hood. The first is what we call a block blob, and block blobs are designed for streaming file information. So for streaming basically whole files back to the client. Right? So in a block blob, we upload each blob as a series of blocks. Those blocks can be up to 4 megabytes in size. We then do what's called put a block list, and that basically says all of the blocks I've just uploaded, they are part of this blob. Maximum blob size of that is 200 gigs, and we implement optimistic concurrency via e-tags. Everyone familiar with e-tags? E-tags are basically a versioning mechanism in the HTTP standard. What that means by using e-tags and the fact that blob storage supports e-tags out of the box, it means if we have a blob up in blob storage and Internet Explorer downloads that blob and then we go back and visit that page again, Internet Explorer is going to have a look at the e-tag. It's going to call up to the server and say, only send me that file again if the e-tag has changed. So we get automatic versioning support out of the box. Don't have to do anything as long as we have clients that are e-tag aware. We then have what we call page blobs, and page blobs are really targeted at drives. You may find a use for page blobs yourself. right? But they are really targeted at random read-write scenarios where you want to be able to go and effectively read a portion of large files that you have in the cloud. We support up to 1 terabyte in size blobs using page blobs. It does support optimistic locking, but typically you will use a pessimistic locking approach using what's called a lease. So you will take a lease on a blob, and that will give you exclusive read-write access on that blob for a period of time. And in fact, drives build on that lease approach by actually providing you with a driver that runs inside your Windows as your compute roles that manage and maintain that lease for you. So if we talk about uploading a block blob, so the rules for block blobs are basically you can upload a blob on its own as long as it's under 64 megabytes in size. As soon as your blob exceeds 64 megabytes in size, you have to upload it in a block-wise fashion. It actually makes sense to upload your blobs in a block-wise fashion, even if you are smaller than 64 megs. And the reason for that is you can upload chunks in parallel. So you can basically chop your blob up and upload those chunks in parallel. So say we've got a 10 gig movie file we want to put up into the cloud. Right, we're going to put that up as a blob. So we're going to define that as having a blob name, and then we're going to chunk that into blocks. Right? So we're basically going to go through and within that blob name, we're going to put block 1, block 2, block 3, all the way through to block N. So we now have a bunch of uncommitted blocks up in storage, and then finally we do what's called putting a block list. And when we put a block list, we basically say, all of these blocks in this list make up this blob, commit that blob for me. Some of the neat things around this is that you can retry blocks, right? So you can, if you have a failure halfway through, you can keep a track of which blocks you've uploaded and carry on where you left off. Right, so it gives us really efficient retry. And in fact, we've got some sample applications that we've built at Intigen where we use Silverlight as an upload client for blob storage, and we actually use isolated storage to keep a track of what we're uploading. And we can start an upload, close Internet Explorer, pull the power cable on the back of the desktop PC, plug the power back in, reboot the application, start up Internet Explorer again, browse back to the web page, and our file upload will carry on from where it left off. Which is kind of funky, right? Because who's had pain points uploading big files before with an HTTP upload control, right? So this fixes that problem. Using Silverlight to upload into blob storage means two things. One, we don't need anything to actually host our ASP.NET page in the cloud. So we don't need to run Windows Azure Compute, which means we save ourselves $80 a month by not having that reliance on compute. And two, it gives us all of this retry and an ability to upload very, very large files very, very simply. So page blobs, completely different. All right, so with page blobs, we basically create a blob and we specify the size. It is sparsely stored. That means you'll only be paying for the actual pages of data that are stored on disk. Those pages are 512 bytes in size, so it's pretty granular storage. So basically you've defined your blob and you then end up with a 10 gig address space into which you can start writing data. We can have complete random access to that, so we can write data at any range within our page blob. We can delete data at any range within our page blob. All right? So we work with this as a range that we can push data into and read data out of. So if we then do a get range, if we get all the data within that range, it's going to return us two valid data ranges. Right? It's not going to return us the whole lot, it's just going to return us those non-empty data ranges. If we do a get blob, right, for a given range, it is actually going to return us that full range of data with the empty data zeroed out. Again, you'll find that most of your use of page blobs is likely to be restricted to when you use drives. Anybody any questions so far? Is this interesting? Is it new? Think of some ideas how you might be able to use it at 15 cents per gig per month. All right? Anyone pay 15 cents per gig per month for their SAN storage? No? Anyone pay even one order of magnitude more than that? Right? You'd be happy if you paid $1.50 a month, yeah? So, we spoke earlier about the fact that security in blob storage is really simple, right? It's either private, in which case we need to sign all of our requests to the storage endpoint, or it's public, in which case any Tom, Dick or Harry can get to it. That's not always going to be ideal. Right? There are going to be times when we actually want to have some way of giving a trusted user access to our data. And the way we do that is we use a thing called shared access signatures. And shared access signatures allow us to create a digitally signed URL that provides an elevated set of permissions to a blob or a container for a specified period of time. So I have a blob sitting in blob storage, and I want to give you read access to be able to download it. How do I solve that? I create a shared access signature that says you have access to that blob for read purposes for 10 minutes. I give that URL to you, your client pulls that content down. So basically we take the URL, we add some properties for the expiry that we want to set, and then we digitally sign that URL using our storage key. The beauty of this is that we never have to compromise our storage key. Because the other option is, if you want to get download access to my blob, I'll give you the storage key. You let me know when you're finished, and I'll go to the Windows Azure portal, and I'll recycle my key. That's not particularly practical for most application purposes. Right, so we basically create these time-bounded permission sets. In order to revoke these rights, we have to do one of two things. We either get revocation by the fact that the time expires. The other way we can get revocation is we use what's called a container level policy. So we actually define a policy at the container level, and then we create a pointer to that policy from our shared access signature. That way we can delete the policy later on, and it effectively revokes that URL. If you don't follow one of those two approaches, you are not able to revoke. Right? So you effectively have a hot URL out there that has elevated permissions. You must treat that URL as a pretty sensitive bit of data. Right? Treat that URL as you would treat things like password data, as you would treat any other type of encryption key. So we have two broad approaches to using shared access signatures. The first is what I call ad hoc signatures. So in ad hoc signatures, right, we have our blob, and we then specify what resource we want to provide elevated rights to. That's either going to be at the blob level or at the container level. We specify an access policy, which is a start time, an end time, and a set of permissions. And then we create a signature of those fields using our key. Right, using the storage account key that only we hold, that we hold on the server. We can then send that URL down to the client, and that client can use that URL to download that protected blob, or indeed to upload into that protected container or protected blob for that period of time. All right, so we have our signed resource. In this case, it's a container. We have a start time. We have an end time. So I'm providing 10 minutes here. We're providing write access to the container. And we've got the signature that signs all of those parameters and basically creates that valid URL. That's really good for scenarios where you want to provide quite a short-dated, simple download URL. Right? Good for doing the download scenario. There are times when you want to have longer-dated URLs. For example, when you want to give an application permission for a period of time, maybe weeks, maybe months, to upload content into a container. Right? Think of sort of partner scenarios, software as a service scenarios. If we're going to do that, it's actually quite dangerous to use ad hoc signatures. And the reason for that is if we've given someone a 30-day URL and 10 days in we decide we don't like them anymore because they haven't paid their bill, the only way that we can revoke that access is by deleting our container. Now, if that container is fundamental to some other part of our application, we're basically stuffed. So what we do instead is we use what's called a policy level signature. So we're able to create permission set policies at the container level. So we create a similar set of start time, end time, and permission set as a policy definition at the container level. We can then reference those policy definitions in a shared access signature. That means if we create a shared access signature and we want to revoke it, we simply go back and change or delete that container level policy. So again, we have our signed resource, we have our pointer to the container level policy, and we have our signature. That allows us to provide a revocable permission set to the client. And it means it's a whole lot safer to provide long-dated shared access signatures. So let's have a look at this in action. So I've got a simple Silverlight upload client that we'll probably make available via my blog after TechEd. And we have implemented a Silverlight-based upload library for you to be able to upload content into blob storage. Because the Microsoft-provided storage client API library does not compile for Silverlight. It's not Silverlight compiled, so you can't use it from Silverlight. So we've written the code to basically make those RESTful calls for you and to do block-based upload and a few things like that. So in here, I've got my simple application. And I've got a simple Windows Azure storage client application that is a Silverlight project. I also have a website. This is just a plain old ASP.NET website. This is not a Windows Azure site. If I run this up, what you're going to find is I'm going to look at creating a shared access policy in my code. Right? Because I'm going to take that shared access policy and I'm going to provide that to the Silverlight client. Right, so here I have, and I'm going to need to zoom in on that. There's my shared access policy. So you'll see I've set a start time. I'm providing those permissions at the container level. Right. I am actually using a container level policy in this case. And I set that container level policy in a simple admin page. So over in my admin page, I have support to create a policy and to revoke a policy. So let's have a look at this actually working. So I'm going to leave that admin page open. I'm going to come over here to, not the admin page, to the default page of this site. Knock off some breakpoints, going to turn these breakpoints off. So I've got a very simple little Silverlight client here. I've got an area to drop files, so I'm going to be able to do drag and drop upload. And I've got an ability to specify the cache control max age on the blob. And we'll come back to why I'd want to do that shortly. If I grab a file, let me jump into pictures, grab a koala, and drop that koala on. So you'll see I've dropped that into Silverlight, and it's thrown an exception at me. Who can think why that might be? Maybe I haven't got permissions, right? Maybe I haven't got a policy. So what I'll do is I will go back and I'll create an access policy. I can check that I've actually got an access policy because I can come down to my TechEd New Zealand container here in my cloud storage studio. and I can have a look at my container policies. And you'll see at the moment I don't have any container policies. So if I create a policy, that's weird. Okay, so I've now got my container access policy. It was a refresh issue. Right, so you'll see here I now have a policy called Silverlight Access that provides write permissions that I can now reference inside my shared access signature. Jump back to my page, reload my Silverlight page because I need to regenerate that shared access signature based on this new policy and send that down to the client. And I should now be able to drag and drop files and have them uploaded directly from Silverlight up into blob storage. So you'll see it's uploading, and it's uploading in a block-wise fashion. So it's basically uploading my 1 meg file block by block. So that's now uploaded. If I jump back to Storage Studio, refresh my container, you see I now have penguins uploaded into my container. One of the neat things is I can go back now and I can actually revoke that permission set. So I can go and revoke that policy back off the client. If I now go and try and do an upload, say the jellyfish, you'll see I'm not going to be able to upload anymore because I have revoked that policy from my client. So we now have fine-grained permissions with revocation. Right, it means I can now upload content directly from the client's machine into the cloud. It never touches my data center. Right? So I'm never paying traffic costs on it through my data center, which particularly here in New Zealand, because I know what traffic costs because we have data center, is really quite beneficial. Okay, text-heavy deck. So, the Windows Azure Content Delivery Network. So a content delivery network is basically a mechanism that we can use to spread our content to remote geographic locations and then have them served to clients from the nearest node to them. So to give you an example, Microsoft's Windows Azure CDN has nodes in Singapore, Hong Kong, Los Angeles, Seattle, San Francisco, Sydney. So if we pull some content from here in New Zealand out of a CDN-enabled container, we're going to get that content from the Sydney data center. Right, so we intelligently determine which location we should be routing the request to based on the geographic location of the user. So CDNs have been around for a while. And there are a couple, 3 or 4 commercial CDN providers. Some you may have heard of, people like Akamai, people like LimeWire. So you can go and procure CDN services from those people. The issue is that their CDN services usually come with a pretty hefty price tag, right? And you're usually making a pretty big commitment to be able to use the CDN. You're usually signing contracts and doing all that sort of muck around. With the Windows Azure CDN, I can basically say, turn on the CDN for my account, and at that point any public blob can be accessed through the CDN URL. Which means any public blob can be spread out through Microsoft's now 20 location content delivery network. So what you're going to end up with is you're going to end up with your Windows Azure blob URL. You're going to have a Windows Azure CDN URL, which is what we get when we enable the CDN. And then if we want to, we can actually map a custom domain for that CDN. So you can have cdn.mycompany.com, And it will look, to all intents and purposes, like you have a full commercial CDN. Using a CDN is one of the key parameters for high-performance websites. Anyone follow the stuff that Steve Souders does? Steve Souders, high-performance websites. Anyone ever used YSlow? Firebug YSlow? One of the key things you're rated on YSlow is whether your content is served up out of a well-known CDN. This gives you CDN for a pittance. So, how does it work? We've got our blob sitting in Windows Azure Blob Storage. Our user makes a request to the CDN URL. All right? So we've enabled, holy cow, that doesn't look very good, does it? We've enabled the CDN for our Windows Azure storage service. We need to make sure that all of our blobs are public. We only get CDN access for public blobs. Hope that's reasonably obvious. We need to make sure we set the cache control max age header on that blob. Our user does a request at the Azure CDN endpoint for that particular storage account. That request is going to be routed to one of the edge servers. So those are one of the geographically disparate servers spread around the world. That server has a look in its local cache. Is there a copy in the local cache? No, there's not. It then determines which Windows Azure blob container it's serving up, and it goes and fetches that content from Windows Azure, from the blob storage endpoint, and it caches it locally. It then returns it down to the client, right? But it's going to cache that for a certain period of time. That's the time to live. That time to live is set using the cache control max age header. If you've got a really high load website, there's no issue with actually making that time to live something like 60 seconds, right? You want the CDN, you're prepared to tolerate data that's staleness is 60 seconds old, right? But you actually want to take advantage of all of those CDN nodes. So now our clients, when they get routed to that edge location, are going to be able to pull that data directly from the edge server. So if they get routed to Sydney, that data is now sitting in Sydney and can be returned to us directly from Sydney. Once that content expires, we're going to go back through the same process. The edge node is going to go and retrieve that content from the originating server. Does that make sense to everybody? Can people see why that's kind of useful? Yeah? For those who use CDNs already, do you think that's cheap? It's actually... Yeah, you do. So you pay for traffic. You pay for traffic from here to here, right? And then you pay for traffic from here to here. But the freaky thing is, right? If you're using the Asian data centers, that would sound like my laptop switching off. That's good. If you're using the Asian data centers, serving out of the edge nodes is cheaper than serving directly out of blob storage. So if you're using blob storage and you have it in Singapore or Hong Kong, right? North Asia or Southeast Asia, you'd be a complete mug not to turn on the CDN, right? Because your bandwidth costs are basically half to serve out of the edge servers rather than out of the origin server.
So if you have a website, for example, that was only accessible in New Zealand,
yes.
it still makes sense to have a CDN even though you'd only have to go to Sydney for your data.
Correct. Yep. So if it's only ever going to be accessed from New Zealand, but you still want to take advantage of it, yeah, push up into blob storage in Singapore, turn on the CDN, and then it will typically only be served out of Singapore, out of Sydney. There's no guarantee it'll only be served out of Sydney, because the algorithms that determine the routing may sometimes say, well, actually, I think I've got a shorter path to Los Angeles than I have to Sydney because I'm on Telstra Clear, and Telstra Clear route traffic from Wellington to Auckland via Los Angeles because they don't peer, right? Or one of those ISPs that aren't big on peering. Yeah, so there's no guarantee it's always going to come from Sydney, but that's a really sensible way to do it. And again, if you need to set a short TTL, right, that can make sense as well. So, let's have a look at what the CDN looks like. So if I jump back into my storage account, you'll see I have the CDN endpoint enabled for this account, and my CDN URL is az7630.vo.msecnd.net. That's a pretty fugly URL that you don't want to be sending down to your client typically. So what you can do is you can map custom domains against that. I have not chosen to do that in this case. But typically you'd want to have cdn.mycallcompany.com mapped into that endpoint. So what that means is if I jump over here to Cloud Storage Studio again, and I've got Penguins up there, and in fact Penguins is a publicly accessible blob. The only thing I can't do in that container is I can't write to that container without a shared access entry. But I can open this blob, so I can get the URL for that. I can come over to Firefox. Who's looking forward to getting Firebug-like features in Internet Explorer? Yes. We're going to use Firebug here, right? Because we want to have a look at this network traffic. So I'm getting this from the blob storage endpoint, which is located in US South Central. So that's basically coming from Texas. It took 8.93 seconds to come from Texas. If I head back over here and grab the URL for the CDN, and I jump over here, and I go tens, whack, penguins.jpg. A word of warning, folks, this stuff is case sensitive. That will get you really confused really quickly. It is case sensitive. So if I jump over and grab penguins here, now obviously the first request is probably going to take a little while. Why is it going to take a little while? Because it hits the edge node in Sydney. The edge node goes, I don't have this, I'm going to go to Texas. Sydney goes to Texas, picks it up from Texas, brings it back to Sydney, and sends it back to us. So it takes a little while to warm up the cache. Right? Quite a while to warm up the cache. Yeah? So, if you use this, there may be situations if you're doing fast refreshes where you want to have something that sits there and actually keeps your cache pre-warmed. But subsequent requests should be significantly faster, as long as I actually have the TTL set, which I think I did. Let me just check I actually set the TTL correctly on this. Create my policy again. Set my cache control to be a day. Let me chuck the koala bear up. And give that a refresh. Right, so we've now got a warm cache in Sydney, obviously, right, because we're now down to sort of 6 seconds or so to download my 1 meg file from Sydney. And you'll see there's probably some stuff going on in the caching server where it's being moved around based on the sort of request frequency we're getting. So potentially it's now being cached in memory as well as being cached on disk. And you'll see it does get faster as we go through and access that blob more and more. So I'm doing a hard refresh here every time, Control F5 every time. So CDNs are a brilliant thing for making really fast websites. Typically they've been out of the reach of the vast majority of people, which has probably had only 2 hands saying, yes, I use a CDN in the room. With the Windows Azure CDN, you can have a CDN for a pittance. Right? The one thing you can't have at the moment, which would be quite nice, is an ability to specify an origin server, right, other than Windows Azure blob storage. Right, to basically make my server on-premise the origin server. But the example I gave yesterday was if you've got a really high-load website, right, rather than have users hit your high-load website themselves, the election results, Australian election results, right, you've got a high-load website. Probably don't mind if the results are 60 seconds old at any point in time. So rather than serve directly out of your ASP.NET server, hide your ASP.NET server, create a spider that basically spiders your content every 60 seconds into blob storage, and then point your users at blob storage. And you basically have unlimited scale on tap, and I reckon you can probably host the Australian election results for under $50, which is a pretty compelling scenario, I do believe. So we've tracked pretty well to time. We're not going to talk about drives. What we're going to do is open the floor to questions and just have a bit of a chat about what people thought of that. Why would you ever use a Singapore data center? We have a client in Perth. The Singapore data center is 6 times faster for them in Perth than the US data center. Here in New Zealand, I haven't actually done any Perth tests comparing the data centers from here, but I definitely did do Perth tests in Perth because we thought, bugger it, we're not going to go and use Singapore. It is about 5 or 6 times faster from Perth to use Singapore than it is to use US South Central. South Central is Texas, North Central is Chicago. Yeah.
What advantages do you see of this product over Amazon's S3 storage?
It has a few more nodes in the CDN. It's pretty familiar and easy to use for Microsoft-based developers, so you have a really rich managed. The question, sorry, I should repeat the question. What advantages do you see of this over Amazon's S3 service? So Amazon have an offering that's very similar to this. So the key benefits, you get more nodes in your CDN, right, which is pretty good. And the other is that you get a really rich managed .NET library so that you can do all of these fancy things like shared access signatures and so forth from .NET-based code. So if you're building .NET-based applications, it's a complete no-brainer. It's pretty good when you use it from other platforms as well. Other questions, folks? Stunned in amazement. All good. So I'm going to hang around probably outside for maybe 15, 20 minutes or until everybody's sick of talking to me afterwards. Thank you all for coming along. Please do fill out your evals. There are great prizes to be won. And I do appreciate any and all constructive, destructive, or reconstructive criticism and feedback. Thank you all for coming along, and we'll see you again either next year or at some sessions tomorrow. Thank you.